Please welcome Principal Architect, Concur, Dan Wilson.
Hi, thank you. I have the pleasure of speaking after lunch and trying to wake you guys up a little bit. So let me tell you a little story I heard from a friend of mine at Concur, actually. He told me about the guy that invented the USB cable. I don't know if you heard this or not, but he died. And when they lowered his casket down, it didn't fit. So they had to lift it back up, turn it around, and put it back down. And then it worked fine. So hopefully that helps wake you up a little bit. And I'll try to keep this as entertaining as possible. We are going to talk about how Kubernetes runs at Concur. We'll also talk about why we picked Kubernetes initially, why we picked CoreOS, and then the Federated Cluster Selector. So before we do that, though, really quick about Concur, we help make it easier for employees and businesses to control spend, and the employees that work for them to get reimbursed quickly while they're still traveling. We've been doing this for a while, and we're growing. Our end user growth has continued to pick up even since SAP bought us a few years ago. And our end users are really important to us. So everything that we build, we have to keep that in mind, that we're building solutions that people are using. They're using them while they're traveling, so they have to be reliable. I've been at Concur forever, since 1998. And I've done various roles at Concur throughout the years. I've been working with Kubernetes since the middle of 2015 when it was 1.0. And I also now contribute to Federation. So why did we pick Kubernetes? Mainly, it was that it's open source. It's not a closed source system. It's not controlled by one primary entity. It was gifted to the Linux Foundation, so we knew we could trust it. You can read through the other reasons here. I'm not going to drain each one. But out of all the other ones on the list, I'd say what has become the most important one is actually the pluggable API and how easy it is to adapt Kubernetes to our environment. And then also the way that we're able to integrate it with our legacy systems by leveraging that pluggable API as well. So why did we choose to run on CoreOS instead of the other operating systems out there? We did it because it was simple. A lot of things were figured out for us already. As you can see here, it was well documented. But there's another aspect of this that needs to that we need to figure out, and that is that when you're building a system with Kubernetes and Docker, there's a lot of pieces involved. And the reason why I have hypercars up here is because it's a lot like building your own hypercar, especially if you're going to go out there and build your own system and get it running into your data center. You have to figure out what version of the Linux kernel do I use? What version of Fleet? What version of etcd? What version of pretty much everything that is going to actually work together? And if you don't piece these things together in a way that they work together and they don't have bugs, then you're going to end up troubleshooting a bunch of issues with all of those interdependencies. And CoreOS has had this figured out for a long time. And they actually publish with every single release what are all the different versions of the components that work together that they've actually tested and made sure that they work. So that was one of the primary reasons why we picked CoreOS, is they had this all figured out for us already. Also, the operating system that we were using in our data centers at the time was pretty far behind kernel version-wise, that Docker wasn't even going to support it. So we were going to have to make some drastic changes anyways in our environment. So it was a perfect opportunity to switch with this new platform and to go with CoreOS. This is a picture of what the pipeline looks like at Concur. You can use Yeoman to generate a scaffolded service, whether it's a Node.js service or a Java service or a Golang service. This gives you a nice template to start out with if you're a developer at Concur. You don't have to use it. It's there to help dev teams get started quickly when they're writing a new service. From there, they check the code into GitHub Enterprise. And once it's in GitHub Enterprise, they can use the CI system of their choice to build and push the Docker container out to Artifactory. Once the container is in Artifactory, instead of running a bunch of commands against Kubernetes directly, we built this penguin that you see up there we call Skipper. I'll talk more about that in a minute. And from there, it gets onto Kubernetes somehow. Now, we've been changing this, actually, and we're still in the process of making these changes, so I can't speak to exactly how well everything works on Quay and how well things work on Tectonic. But this is the direction we're going. It's a shift that we made to help improve our architecture internally. A little bit of a closer view here into our clusters. You can see that we tie our Kubernetes infrastructure into load balancers. This works the same inside our data center as it does in AWS currently. And we also followed as much advice as we could about how to make these things highly available and resilient. There's multiple master servers, which are the Kubernetes API servers, multiple etcd nodes, and then the worker nodes that are running the actual Kubernetes containers. We pulled monitoring and logging outside of the Kubernetes clusters because we have multiple clusters that we're keeping track of. So we wanted to make sure that that was separate. We also run Flannel for our networking stack right now. We're looking at moving to Calico. I want to stop for a second and just let everybody know that you can ask questions too at any time. There's a bunch of stuff for me to get through, but I don't want to just gloss over anybody's questions at any time. If you feel like something doesn't make sense, I can pick it up. So,
are you doing different things with Elk, New Relic, and Prometheus, or are they overlapping data purposes?
So the question is, are we doing different things with Elk and Prometheus and monitoring? Yeah, we're doing different things. Our Elk stack is for primarily our services, our different microservices that are running on top of this platform to send logging messages to. The Prometheus is focused on the Kubernetes infrastructure monitoring. And then New Relic is where we also push all of our custom metrics for our individual microservices running on our platform. OK. So let's talk about high availability a little bit more. There's a great guide out there, out on the Kubernetes site, on how to set up and architect your system, your Kubernetes cluster, so that it is highly available. And I know that Tectonic has invested a lot of time and money into this as well with things like the operator. And it's great, like the things that they've worked on. From what I can tell, they look awesome. But everything can fail. If it can't fail, then, well, there's nothing left for me to do. Like, just build one thing and run your stuff on it forever, and you'll never have any problems. But we know that that's not the case, right? There's different classes of failures for systems as well. And the main thing that I am concerned with on the Kubernetes system at this point is the unknowns, the unknown unknowns, really. So there are known issues with systems. That's one class. Like if I have a database system, I know that at some point I'm going to read and write data onto a table so much that it starts to have lock contention. That's a known problem, right? I can watch for that. I can set up monitoring for it, and I can trigger alerts when it fails. Actually, I said that wrong. That's a known unknown. I know that it's going to happen at some point. I may not know exactly when it's going to happen, depending on my workload. A known is that it runs out of CPU or disk I/O and then starts to melt down. Now, the unknown unknowns are when you don't know what could happen, so you don't know what to monitor and track against to be able to prevent it. And especially if you're working with a new piece of software that hasn't been run in a lot of environments at scale yet, then you have to protect yourself from these known unknowns in an architectural way. And that's why we went with a multi-cluster solution for Kubernetes, since at the time, I mean, this is a year and a half ago, when we were working on architecting this for Concur to be used in production, there were too many unknown unknowns with Kubernetes. Now, a year and a half has gone by, and it's getting to the point now where a lot of those unknowns are well-knowns. So at some point, we will dial back and not have as many clusters. But right now, we needed a way to tie multiple Kubernetes clusters into a single load balancing endpoint so that a given application or service, in this picture, the service is SVC. It's running on every Kubernetes cluster. We're routing traffic for that one service in a single region across all of the Kubernetes cluster. But how does this work? How do you do that today? There's not really a way to do that, at least not easily. And there certainly wasn't a year ago. So what we did is we wrote our own little plugin, the P in the picture there, that watches the Kubernetes API for events. And when it sees changes to nodes or changes to new services, it would call out to our own internal load balancing as a service API and make the changes necessary to load balancing to plug in the correct nodes and services into the load balancing pools. I created a sample project out on GitHub of how this works. I won't get into too many details now, but like I said, it leverages that really nice Kubernetes API. There was a talk right before this in this room by a CoreOS gentleman, I think it was Aaron. They also demoed how they're using the same API to do Kubernetes operator tasks. So it's very powerful, and feel free to check it out, contribute back to it, or fork it and do whatever you want with it for your own internal purposes. Some other examples of where this might be useful and what I've seen people use it for is just taking the event stream from Kubernetes and pushing it out to your own change control system so that you know exactly what changes have happened in the Kubernetes system. Another example of this that I've seen is watching for individual images or container images running on the Kubernetes cluster and checking if they're trusted or not. But don't write your own F5 integration like we did. Instead, F5 has done that for you. This is relatively new. You can just go out there and download it and run it onto your Kubernetes cluster. I haven't tried it yet, but I've looked through it and I've spoken to them about it quite a bit, and it looks really good. So check it out. Okay, how do we do upgrades of our clusters? We try to treat our Kubernetes clusters just like cattle. And instead of actually changing them, we just blow them away and create new ones. But that's harder to do if you don't have multiple clusters already tied into a single load balancing endpoint. So it's something to consider as you're designing your system. This isn't necessarily the only way to do things, but for us it was the safe bet. We would build out a new set of clusters on a new version, and then once deployments of services are running against both sets of clusters, the old version and the new version, and we were confident that the new version was performing and stable enough, then we just get rid of the old version. But this brings to raise some other challenges with Kubernetes in your own environment, with multiple clusters. How do you get your deployments to actually run on all of those clusters? There's different approaches to this. One is to have everyone run individual kube control or kubectl commands, whatever you're preferring to call it these days. I got used to calling it kube control, and then I heard everybody saying kubectl, so apologies if I'm saying it wrong. Another way is using a spec repo. This seems to work really well, where you take all of your YAML or JSON files and put it into a single GitHub repo, and then as clusters need to be updated, you just clone that repo and run kubectl apply against all the objects, and all of the deployments then get rolled out to that cluster. And that works really well if you have an environment where every single service gets deployed to every single cluster in exactly the same way. But I don't live in that world. You can also build a custom pipeline to do some interesting things here, like store copies of the objects for each environment in a separate spec repo, and run kubectl itself, or make the Kubernetes API calls. Or you can write your own custom API. I'll talk more about that in a sec. So we've tried some of these different options, and we found that there's some problems just trying to get them to work. One is, how do you know what the different clusters are? You have, in order for kubectl to work, you have to have that local config. And if you don't have an automated way of updating those configs, then you might be trying to push deployments out to a cluster that doesn't exist anymore. You might not know about the new cluster that's the new version. Also, all of those commands have changed a lot over time as things have gone from pods to replication controllers to deployments to stateful sets to whatever else. All of that YAML needs to be updated. And if it's spread out in God knows how many different GitHub repos or CI jobs, or if you have this massive spec repo that's full of all of your deployment YAML, then who's going to go through and update it so that it's the latest version and it has all the right annotations in it for your environment? It could get kind of messy. There's credentials that you'd have to handle, and then environmental things like, is there one environment in your business where you can actually access the endpoint of all the Kubernetes clusters? Are you going to have to design your system so that it can talk to multiple proxies and route the requests using the right credentials? A lot to consider. So we created Skipper. This is a very lightweight layer, thin layer on top of the Kubernetes API that developer teams can just describe their simple set of primitives that they want deployed. It's a condensed down version of the Kubernetes YAML that just contains the image or set of images that you want to run, the ports it runs on, and how many copies of it I want to run, and then which zones I'm running it in. So a lot like what you saw this morning with Borg, where it's a very shortened, condensed version of the YAML. So in our environment, it looks like this. The CI system just says, hey, I want to deploy the Pet Shop app to test. And Skipper knows what test is right now. It's these 3 Kubernetes clusters that are test. And it just turns that into the right Kubernetes YAML to get it deployed in our environment and makes the API calls out to those clusters. And then if I wanted to deploy the same thing to prod, well, it would know that prod means I'm deploying it to these 3 different regions across 3 different clusters in each region. Well, after we had that up and running and working and needed to switch out our Kubernetes clusters to the next version, we decided that it would be better if we actually gave the operations team an API where they could call Skipper and just tell it about the new cluster and remove the old cluster without us having to manipulate the configuration. So we added that API to it. And developers also needed a nice, easy way to use kubectl locally. So we wrote the setup API that they just call it with their credentials, and it outputs the Kubernetes kubectl commands that will actually generate the config locally for them. And it was done this way so that it doesn't clobber your local config. If you already have Minikube set up or your own local Kubernetes cluster, you don't want to have to just replace that config file or merge the 2 together yourself. Yeah, there's techniques for handling that with environment variables and whatnot, but we decided to just make it easy. So what started out as being this really thin layer on top of Kubernetes started to get a little fat because, well, we added a bunch of stuff to it. And I don't know about you, but anytime you write a tool and it starts to get too big, you start to look at maintaining it and what it's going to cost to keep it running. And we decided to try to thin it out a little bit. So it was at the KubeCon conference in Seattle last year that I first talked about Skipper, and some folks from the Federation SIG were in the talk watching it, and they said, hey, you should really consider contributing some of that back to Federation. And that's, over the last 6 months, what I've been working on. So the first piece of that is the cluster selector that I was able to add into Kubernetes 1.7. And then we're looking at other potential improvements to Federation that we can make beyond that. So let's talk about cluster selector. In order to use the cluster selector, you have to use Federation. And there are some great guides out there already on how to get Federation up and running. Thank you to Kelsey Hightower for doing his Kubernetes Federation the hard way. And also now there's some really good docs out there in the kubernetes.io site on how to use kubefed and stand up resources on GKE for Federation. I think that you're going to see a lot of improvements here as well about how to do this locally inside your own data center and across various cloud providers. So keep an eye on that. Another thing I should mention is Federation on Kubernetes is alpha. So it's still being changed. The API is not locked in. I think we're getting close to being beta, and possibly in the 1.8 timeframe, it'll be officially beta, but we'll have to wait and see what gets into this next sprint. So once you have Federation up and running, you can label your clusters, just like you can label nodes in Kubernetes and give them different attributes. It's a very straightforward command. You just run that command against your federated context. And then once your clusters have been labeled, you can add an annotation to any of the Kubernetes objects that the cluster selector feature uses. So you can see alpha in the annotation name right there. You can also see that there's JSON that's being stored as the value of the annotation. And that JSON needs to be parsable, obviously. So you have to make sure that, that you don't have a typo in there, like a wrong quote type or anything weird like that. And there are three pieces to that that we'll go over in a second. The object types supported in Kubernetes 1.7 are listed here. The replica set and deployment, which I have a typo on, that's cool, are gray because it's unknown whether or not those will make it in before code freeze tomorrow. There's a few pull requests that haven't quite made it in, so we'll find out. Deplopment, yeah, awesome. Okay, so these are the components of the cluster selector itself. It takes a key, an operator, and the values. The key is what matches the label on the cluster object. The operator is how you want the match to work. Is it an equals, or an in, or an exists? And then the values are the label values. Just a closer look at the operators there quick. You can even do greater than, less than, which is interesting if you need to check a version of a component. So then, how this looks is instead of sending your objects directly to each cluster, you use kubectl or the API to send your objects to the federation context. And then federation will inspect the cluster selector annotation and determine which clusters the deployment gets sent to. Much the same way as what we had done internally at Concur with our own API, but now it's all native technology. So we'll run through a few examples here. One is if, let's say, I had segmented a group of Kubernetes clusters and designated them as being PCI compliant. Well, now I can label them as PCI compliant, and I can add that annotation into the services that need to run on PCI compliant clusters. Likewise, I could also say run everything else on non-PCI compliant clusters. So I could just say not equal to true on the annotation for anything that doesn't need PCI compliance. Another example is I just want to deploy it onto all the test stuff. I don't want it to run on production. So not equal to production, or I could have an in clause there that says I want it in various other environments. Oh, backing up just a second. Notice this, in this case, I'm deploying a secret. Oh, really exciting. What if I need to deploy a secret to the US that's different than the secret in EMEA, and different than, and then another different secret to Asia Pacific? I could do that, designate each individual secret, and bind up the real secret values, obviously at execution time, so you're not storing them in GitHub. But then I could deploy my service to all clusters. I didn't highlight that right, but all clusters, and leverage that secret without any complexity. So just again, quick an overview here. To use cluster selector, you label the clusters, and then you specify the cluster selector annotation. Little thank you call out to the API machinery folks that wrote the matching logic that I'm leveraging here. And I'll open it up for more questions.
So are you guys still using Skipper in production, or are you moving to Federation?
Okay, so the question is, are we still using Skipper in production, or are we moving to Federation? We still use Skipper. It is very much another one of the many tools we have in our environment that are optional. So dev teams can choose to use it. A lot of them do, because it makes it easy for them. Eventually, we will get to using federation in production. We are not using federation in production at all right now. And I think that over time, we'll be able to yank more and more code out of Skipper so that it'll become lighter and lighter weight. But we may or may not keep it long term. It's yet to be determined. So.
Do you know anybody that's using Federation in production yet?
Another question is, do I know anybody that's using Federation in production yet? No, I don't know anybody that's using Federation in production yet. It's, like I said, it's alpha. It doesn't stop anyone from doing it. I'm sure that there are people that are, but the API could still change at this point for how Federation works. And it's going through a lot of refactoring. In fact, it was part of the challenging aspect of getting this feature in is that every time I had the pull request, passing all the tests, and reviewed, there was another refactor, and I had to rebase and change everything. So the good news is there's a lot of great resources on the SIG Federation team right now. I called out Maroon and Nikhil, because they've been tremendously helpful. And Maroon has been the guy who's doing the refactoring of Federation controllers, and he's doing a tremendous job, like making it much more scalable and adaptable than it is currently. So look forward to those changes in 1.7.
A lot of the use cases that you're outlining here with cluster selectors sound a lot like the node selector use cases. Are we thinking in terms of taints and tolerances for clusters as well as nodes?
Yeah, that's a great question. I think that eventually that will become a requirement as well on Federation. So far, it has not become a requirement to have taints and tolerances, but I think it's a big potential that we would need something like that. Yeah, it's that's another challenging aspect of Federation, by the way, that new features coming out into core are much more rapid than new features moving into Federation. So if you think about it, there's thousands of people working on core, and then a small handful of people working on Federation. There's just one SIG Federation group. So getting all of those new features added into Federation takes a lot of work, and there's not as many resources to get it done. So contribute, help out.
On deployments across multiple clusters, have you found any good patterns that work for, say, configuration or variables that might need to be a little different for every deployment on every cluster? Do you use config maps or something else?
Yeah, there's a lot of situations like that where deployments end up looking a little bit differently in each environment. I'd say to the best degree possible, avoid doing that, just because it makes things easier to operate. But there are cases like that. Like in our case, it was, I'll give you one example. One example is that for us, in each data center right now, we have a different endpoint that's our Docker registry. So even something as simple as the image name looks different in every data center. Well, that's our own doing, right? We could have designed that better to not have to have that difference in each data center. But we didn't know we had to at first, and we didn't really think through it all the way. Now, as we're redoing things and moving to Tectonic, we're going to try to fix that one. That's one more thing that Skipper's doing today that it just won't need to do.
Hi, the question I have is how often do you guys deploy to production?
How often do we deploy to production? I would have to get a real stat for you. I'd have to look it up. Each end-to-end team can decide when they're deploying to production on their own. Some end-to-end teams decide that they have a release branch, and then anytime the code is merged into release, it builds the container, it runs through the tests, and it actually calls Skipper directly and gets the rolling update going on production directly. But most teams like to have those as isolated tasks, right? That the code push or the code merge is independent of the decision to go to production. And that is one nice thing about having a very simple API for having that deployment run, is they can just say, curl skipper, and then it gets rolled out. Or maybe even write their own Slack bot that says, when I say deploy to production, just go do it, right?
Thanks. So if I understand it, Skipper, you have sort of a simplified developer-friendly language that goes in one side, and then Kubernetes comes out, API comes out the other. What are the key elements that your developers have sort of latched onto in that simplified model? Like what do the developers need in that API?
So I have, maybe the best thing for me to do is to answer that is to send you a link to the Skipper API. I've actually made the API itself public, if that's something you're interested in. I'll just, the deck that I store out on the presentation, I'll just add it in there, because I've talked about that at previous shows.
So the way I understood your use case for federation is that you use it to put a layer in front of multiple Kubernetes clusters, multiple environments. And the way I understood federation was it was used mainly to put a layer above multiple regions, So do you, when it will be V1 for federation, when it will be stable, do you suggest, do you hint us to use one federation over all the environments and all the regions? Or are you gonna still isolate environments or regions or the others?
Yeah, I think that's very much a question that you'll just have to figure out what works best for your environment. Like, what are your jurisdictions that you need to deploy to independently? Do you have requirements that state that data locality needs to stay local, and how are you going to architect that with Kubernetes in different regions? I don't have like one size fits all answer for that. I think it's just going to depend on what your needs are. For us, we like strong isolation between the regions, but some service teams are unimpacted by that, right? They can just run their service the same way in every environment, because the scope of the data that they're accessing and touching doesn't matter, right? It's out of scope for all of the compliance requirements. For other teams, everything needs to be completely isolated and independent because of security concerns or different jurisdictions. So.
Thanks for the nice talk. Can you add a little more details about what kinds of problems you have when you manage these multi-clusters, and what kinds of problems you are trying to address using the federation?
Yeah, so what are the challenges? I think that the biggest challenge is that the clusters, the services that we have today can't always be just run across every single Kubernetes cluster independently. So we need to have some sort of director in front of Kubernetes to direct different services to different localities, or some solution for that, right? That's why we ended up needing the ability to send deployments by label across a set of clusters, and that's why we contributed the feature to Federation.
Hey, so just on that, I guess back on that security kind of point around your segregation of environments, with things like, you mentioned the slides like PCI compliance, obviously like that's probably your most locked down, segregated environment. How do you manage the fact that you're now putting like a control plane on top of it, which has access to like those multiple environments? like, are you not then just giving, access to that to a whole bunch of places where, like, you shouldn't, kind of thing?
Yeah, that's a really valid question. There is a active design discussion right now in Kubernetes Federation about how to isolate control from the federated controller to the individual Kubernetes clusters. Right now, it all runs on a single service account, and that's just not going to fly for the auditors in a PCI compliant type of environment where you need to have true segregation of everything for that environment. So participate in the discussion out there. Look it up and join in. I think there was someone back here that had a question, maybe, if we have time.
We have time for about one more question.
Okay.
So you mentioned one of the main reasons you were using, or earlier in the slides, you mentioned the reason why you were using this Kubernetes aggregation or federation. I forget the name, Sailor or something like that. Skipper. Was to abstract the different Kubernetes cluster versions. Moving forward with Tectonic, since Tectonic makes migrations and upgrades fairly easy, do you feel like that's less of an issue going forward?
I think that will be less of a concern long term. Even with our Tectonic architecture that we're looking at right now, we'll still handle major versions upgrades the same way. The minor revs, though, I think we'll be perfectly comfortable using the upgrade option within Tectonic to maintain the upgrades and make sure that it stays online.
So
I think long term, yes.
So right now you're running you run multiple versions in production simultaneously of Kubernetes, and that's a normal thing?
Yes, that's normal. Yep, we blue-green it just like everything else. So. Okay, I think that's it. So thank you. If you have any, feel free to ask me any questions afterwards as well. So thanks.